See, after completion of this displacement current, now we see how these electromagnetic waves are produced. See, accelerating charges can produce electromagnetic waves. That is, variation of electric field with time can produce magnetic field, and variation of magnetic field with time can produce electric field. Now, these two electric and magnetic fields are perpendicular to each other and perpendicular to the direction of propagation, and such a waves we call it as a electromagnetic waves. Now we see the diagram of electromagnetic waves. See here, this is z-axis, x-axis, y-axis and z-axis. Then, and this is the electric field vector, and this is the magnetic field. See, here it is, the electric field is varying sinusoidally with the time, and this is magnetic field, it is also varying sinusoidally with time, and this electric field and magnetic field both are perpendicular to each other, and the equation gives Ex is equal to E naught sine omega t minus kz, and similarly Vy is equal to V naught sine omega t minus kz. See, Ex is equal to E naught sine omega t minus kz, and similarly Vy is equal to V naught sine omega t minus kz. See, these are the electric field vector which is perpendicular, and this is the magnetic field vector, this is also perpendicular. Next, this electric and magnetic field both are perpendicular to each other and also perpendicular to the direction of wave propagation. Such a waves we call it as a electromagnetic waves. This is the electric field equation, this is the magnetic field equation, and this E naught and V naught are maximum values of electric field, maximum values of magnetic field, and these two are related by equation C is equal to E naught by V naught. C is equal to E naught by V naught. See, now just now we know accelerating charges can produce electromagnetic waves. Already Maxwell already detected the existence of electromagnetic waves, but practically German scientist namely Henry H, who detected the electromagnetic waves by using a simple experiment. What is that experiment you see? See here, he connected one oscillator, and the connections are given to one plate here, this center plate. Between these two plates, they are connecting two small spheres. When the circuit is completed, here the charges is flowing. It is act like a capacitor, and it is act like a transmitter. And here, at certain distance, he kept two more spheres. This is named S1 dash and S2 dash, and these two are connected with wire, and these two are acting as a receiver. Now, this total system is nothing but a LC oscillator. Already in the previous class, we discussed what is this LC oscillator. An energy which is oscillating between capacitor and inductor and giving undamped oscillations and producing certain oscillations or undamped oscillations, and the frequency of this LC oscillations are given by n is equal to 1 by 2 point into square root of LC. Now here LC oscillator is there. In that LC oscillator, initially the charge is present, the charge is given to capacitor. The charge is given to capacitor, it is stored in the maximum electrical energy, and afterwards, if it is maximum, then slowly it is discharging towards the inductor. After certain time, after t by 4 seconds, the complete electrical energy is converted into magnetic energy, then afterwards there is no change in magnetic flux. Again, this magnetic energy is converted to electrical energy. Like that, the energy is also distributed to capacitor and inductor, and finally it produces oscillations, LC oscillations. By varying these values of L and C, we can generate the frequencies of various frequencies of electromagnetic waves. See, the frequency of this waves is given by n is equal to 1 by 2.2 square root of LC. Now, by varying this L value and C value, we can generate different frequencies of electromagnetic waves. But this is Henry H. Only he produced only 6 meters wavelength of electromagnetic waves. But later, the Indian scientist J.C. Bose also he also discovered the electromagnetic waves of very low wave frequency. But finally, Marconi is succeeded by producing very high frequency electromagnetic waves, and it could travel few kilometers, and that is the fundamental of this always communication nowadays. Completely it is based on this electromagnetic waves. Now we see the different properties of electromagnetic waves. See, now we see the different properties of electromagnetic waves one by one. See, first one, electromagnetic waves do not require material medium. That means, like sound waves requires medium for their propagation. Without medium, the sound waves cannot travel. But this electromagnetic waves doesn't require any material medium. In vacuum also, they can travel. So that is one. Now, these have transverse in nature. Transverse in nature. That means the electric field is perpendicular to the direction of propagation and magnetic field is perpendicular to the direction, whereas electric and magnetic field is both are perpendicular to the direction of their propagation. That is the reason these are transverse in nature. Next, the speed of electromagnetic waves in vacuum is given by C is equal to 1 by square root of mu naught h naught. The speed of electromagnetic waves in vacuum is given by C is equal to 1 by square root of mu naught h naught, where mu naught and h naught permeability and permittivity of free space. Whereas the speed of electromagnetic waves in a given medium is given by 1 by square root of mu e, where mu and e stands for permeability and permittivity of given medium. The speed of electromagnetic waves in vacuum, this is the speed of electromagnetic waves in given medium. Next, the electric field and magnetic field both are related with one equation, that is C is equal to E naught by B naught. The maximum value of electric field and maximum value of magnetic field both are related with like this, or that is will be E naught is equal to C times B naught. E naught is equal to C times B naught. Now the electric field, now the electromagnetic waves can transfer energy from one point to another point. Electromagnetic waves can transfer energy from one point to another point. Now the energy density of the electromagnetic waves for electric field as well as magnetic field. The average energy density of electric field is given by E is equal to half epsilon E square of epsilon E square. Similarly, the energy density of magnetic field is given by B square by 2 mu naught. B square by 2 mu naught. That means the total energy is shared by electric field and magnetic field. Now this is the energy density of the electric field, and this is the magnetic density of the this electromagnetic waves. Half epsilon E square. This is B square by 2 mu naught. Now the electromagnetic waves can transport momentum and pressure also. Next, the electromagnetic waves, its its properties almost similar to light. So that is the reason. What are the properties of light? It is also can exhibit the same properties. What are the properties of light? It can show reflection, reflection, diffraction, polarization. It can exhibit superposition principle, superposition principle, like this. What are the properties of light is there? The total properties also, the electromagnetic waves also can exhibit. So finally, the energy is also nothing but electromagnetic waves. Once again, all of you see the properties of EMFs. The properties of EMFs, you see, the electromagnetic waves, the electromagnetic waves doesn't require any material medium. The electromagnetic waves doesn't require any material medium. The electromagnetic waves are transfer in nature. The speed of electromagnetic waves in vacuum is given by C is equal to 1 by square root of mu naught x naught, where mu naught and x naught stands for permeability and permittivity of free space. The speed of electromagnetic waves in a given medium is given by 1 by mu epsilon naught, permeability and permittivity of given medium. Next, the relation between the maximal electric field and maximum magnetic field is related by C is equal to E naught by B naught, or E naught is equal to CB naught. Next, the electromagnetic waves can transfer energy from one point to another point. Then average energy density is nothing but total average energy density is nothing but sum of its magnetic and electrical, and electrical energy density is given by half epsilon E square, and magnetic energy density is given by B square by 2 mu naught. These electromagnetic waves can transfer momentum and pressure. And next, the electromagnetic waves properties are equal to light. So that is the reason the properties of, what are the properties of light? Reflection, refraction, diffraction, polarization and interference. All the principles these electromagnetic waves can exhibit. And lastly, it can exhibit the superposition principle also. And lastly, these electromagnetic waves cannot be affected by electric and magnetic fields. Electric and magnetic fields. It cannot be affected by, because this cannot be affected by electric and magnetic fields. So all these properties are very, very important. So once again, let's see. The existence of electromagnetic waves were discovered by Maxwell, but practically it is proved by Henry H. Henry H. What is the electromagnetic waves? Accelerated charges can create electromagnetic waves. The varying electric field can create magnetic field, and varying magnetic field can create electric field, and these two fields are perpendicular to each other and perpendicular to the direction of propagation, and such waves we call it as electromagnetic waves. Now, what are the properties of electromagnetic waves? This doesn't require any material medium, and velocity of electromagnetic waves in a vacuum is given by C is equal to 1 by square root of mu naught epsilon naught, and velocity of electromagnetic waves in a given medium is given by 1 by mu epsilon naught square root of. And next, and the relation, and these properties are similar to light. That is the reason they exhibit reflection, refraction, diffraction, polarization and superposition principle, and finally it is not affected by electric and magnetic fields.